Hello friends, so this is the sixth question related to Norton equivalent circuit involving dependent sources. So we have this circuit and we have to find the Norton equivalent circuit across the terminals A and B. Okay, so here there is an interesting thing that this circuit, it does not contain any independent source, any independent voltage source or any independent current source. Okay, no independent source at all. So in that case the Norton current will be 0 ampere. So if you remember in Thevenin equivalent circuit determination also, we took some questions in which circuits contained no independent sources. So in that case the Thevenin voltage was 0 volt. So here, as we are determining Norton circuit, Norton current will be 0 ampere. So IN is equal to 0 ampere. So directly we will go to RN calculation. So here there is nothing to deactivate. So directly we will go to the RN calculation. So for that we will connect an external excitation. Okay. Here plus minus V0 20 ohm, 10 ohm, .5 V0, and here we will connect a 1 volt voltage source. Okay. So this is A, this is B. Now let us assume this current is I0 flowing from this 1 volt voltage. So here these two get added up, one is I0 and second is 0.5 V0. So this will be here I0 plus 0.5 V0. Okay, and the polarity will be like this. Another important thing is that this V0 is actually 20 multiplied with I0 plus 0.5 V0. This is an important equation. V0 is 20 multiplied with I0 plus 0.5 V0. Now another important thing is that this is a dependent current source in between these two closed loops. So we can directly apply KVL in this super mesh. Okay, this becomes a super mesh. So when we apply KVL directly, okay, this whole two meshes combined, starting from here we can write the KVL equation as 1 minus 10 into I0 plus 0.5 V0, okay, minus 10, and then minus 20 into I0 plus 0.5 V0. Okay, so this is equal to 0. Again, if we simplify it, it will become 1 minus 10 I0 minus 5 V0 minus 20 I0, okay, minus 10 V0, it is equal to 0. That implies 1 minus 30 I0 minus 15 V0 is equal to 0. That implies 30 I0 plus 15 V0 is equal to 1. So this is the second equation. This is the first equation, this is the second equation. Now what we have to do is that we have to cancel out V0. We have to figure out a way in which we can cancel out V0 so that we can directly get I0, and once we get I0 we can determine Rn as 1 volt by I0. Okay, so let us do that. So now we have got these two equations, okay, 1 and 2. So let us just simplify this first equation a little bit. So it is V0 is equal to 20 I0 plus 10 V0, that implies 20 V0 plus 9 V0 is equal to 0. Okay, so this is one. Let's say this is the third one. Okay, this is the third one. So now let us, we have got the two equations. Okay, first is 30 I0, let us write 30 I0 plus 15 V0 is equal to 1, and then this is 20 I0, sorry, this is 20 I0, by mistake I wrote 20. Okay, 20 I0 plus 9 V0 is equal to 0. Okay, 20 I0 plus 9 V0 is equal to 0. Now here we want I0. Our objective is to find I0 so that we can get Rn. So we have to figure out a way in which we can cancel this V0 variable cancellation method we can use. So here what we can do, let us divide both these equations. Okay, the first equation, let us divide it by 5, and the second equation, let us divide it by 3. Why I am saying, because then we will get 15 V0 when we divided it with 5, we will get 3 V0 for this part I am talking about, and 9 V0 when we divide it with 3, we also get 3 V0. So when we subtract it, we will get this V0 part cancelled out. So when we divide the first equation by 5, this becomes 30 by 5 is equal to 6 I0, this becomes 3 V0, and this becomes 1 by 3. This becomes 1 by 3. Okay, sorry, this is 1 by 5, which is 0.2. 1 by 5, which is 0.2. This is divided by 5, this is divided by 3, sorry. Okay, so 6 I0 plus 3 V0 is equal to 0.2. Now this one we are going to divide by 3, so this will become 20 by 3, this will become 3 V0, and this will stay as 0. Now we have to subtract them. So minus minus, this is minus, this will get cancelled. So this will be 6 I0 minus 20 by 3 I0 is equal to 0.2. So let us subtract it. 6 minus 20 by 3, which is I0, which is basically minus 2 by 3, because 6 into 3 is 18, 18 minus 20 is minus 2 by 3 I0. So this is minus 2 by 3 I0 is equal to 0.2. 2 by 3 I0 is 0.2. So I0 is equal to minus 0.6 by 2, minus 0.6 by 2, which is equal to minus 0.3 ampere. Okay, minus 0.3 ampere. So we have got I0. I0 is equal to minus 0.3 ampere. So Rn is equal to 1 by minus 0.3, which is become minus 1 by 0.3. Okay, so this becomes 10 by 3, which is equal to 3.333 something ohm. Okay, this. Okay, so this is Rn. Rn is equal to minus 3.3333 ohm. So in the previous questions related to Thevenin circuit, I explained this concept of negative resistance, what negative resistance mean related to power, whether it is being absorbed or whether it is being supplied. So I will not repeat that again. So I have explained this in the Thevenin circuit questions, so you please check those questions. Okay, so here we determined Rn is equal to minus 3.33 ohm. So we got this. So simply using variable cancellation method, we eliminated V0 and we got the expression in terms of I0. Then we used I0 to determine Rn. Okay.